Welcome back everyone to theCUBE here in our Palo Alto studio. I'm John Furrier, host of theCUBE for Robotics and AI Leaders series. This is our second annual event, theCUBE plus the NYSE community together, breaking down all the trends as AI goes next level, as the infrastructure continues to be invested in and extracting that value. We've got a great panel of experts going to talk about the data platform, all the underlying components that are powering everything we see in autonomous vehicles, robotics, and certainly the data centers that are now becoming supercomputers. We got Avi Shetty, Senior Director, AI Market Enablement, Solidigm, David Flynn, CEO, founder of Hammerspace, Hao Zhong, co-founder and CEO of Scaleflux, all CUBE alumni. Gentlemen, great to see you again. Thanks for coming on, appreciate it. First of all, storage is a bad word. David, you always school me on this one. You say it's a data platform. It is a data platform because you're now seeing kind of an operating system we've discussed many times individually and collectively, that the systems themselves are becoming larger scale. So the pressure is on you guys to get the components to be faster, smaller, inexpensive, cost-wise. So this is the pressure point. Networking's hot. Databases are hot. Everything's hot for the agents. David, I'll start with you since you've got the fresh funding. What's your view on this? You've seen the movie before with Fusion IO. You've seen the evolution. Where are we right now in these large scale infrastructure deployments and the explosion at the edge, which really robotics to me represents?
Well, I think we're still at the beginning innings. You know, people think, well, maybe we're on the backside, the trough of, like, I don't think we've even hit the earnest part of the curve yet with operationalizing AI systems and using them in ways that can extract real value for businesses. I think everybody sees the potential in them, just working with LLMs and seeing the advancements that have gone in there. But I think we're only in the beginning innings when it comes to realizing the potential that these things have to offer.
Yeah, Avi, you guys have been such great performers on the business front, on the product side, Solidigm, obviously. You had some pedigree, you're now out in the open, product selling, like hotcakes. Form factor, a big differentiator, cooling.
Yep.
This is the key to get shrinking the density down to fitting into the systems. How do you see the business right now and the world evolving?
John, it's always kind of vectored around four things for us, right? Ever since we've been I think we are part of the Intel storage group, and ever prior to that we were the FPG, the Flash Products group. And for us it's always been low latency, high bandwidth, high density, and lower cost, right? You have those four vectors which you have to optimize your solutions for. And now in the AI world, we've been trying to push the industry, trying to push them to adopt SSDs, but it's actually now where you can't have an AI data center without having optimized, high-performing, scalable solutions. So for us, it's just starting, and we're excited to kind of have a full portfolio of storage solutions for our AI customers.
How you were at the NYSE, we did an interview there. What's changed in your world in the past 4 months? Because networking is hot, the systems need to be tied together. Low latency memory is huge for these intelligence and these computation systems that are designed not as a one general purpose machine. These are large scale clusters. What's changed in your world? How do you see things?
Yeah, it's such an exciting time, and we keep finding the demand for the AI infra is becoming more and more. And the opportunity we're seeing is we have a lot of stuff we need to enable, right, for the robotics and Gen AI. Those are things that we need a tremendous data infra for that. However, we need to keep in mind we have constraint of power. Within the power consumption, we need both capacity for data storage as well as performance for the compute. So how to develop the technology that enable both performance and more capacity with optimization of the power, that's become more and more interesting.
And the physical world is connecting in with digital. This is what we're seeing in robotics. Certainly I call it the edge, but it really is the merging of physical AI. And the question is that what's the next evolution in the infrastructure to make that more of a reality? I mean, there's a general conversation in San Francisco right now question everyone's asking, so when will robots replace the human population? And it's all out there, but 10 years, it's coming.
It is coming, but looking at the here and now and around storage, I think we're witnessing right now a major sea change where heretofore flash has been the performance tier and people have used more traditional architectures with hard drives for the capacity tier. But like Hal mentioned, because of power budgets, we're now seeing flash becoming the capacity tier. Also because you need more performance from the capacity tier than what traditionally disk drives have offered. So higher performance requirements, lower power requirements means we're finally at, I believe, the tipping point where flash takes over the 90th percentile of just bulk capacity and retention, not just the performance sides. So this is a major shift to see.
Let's unpack that, because one of the things I've been squinting through and looking back at the past events over the past 6 months or so, give or take, the theme has been first token out, okay, we check. And then now with reasoning, it brings up, okay, more tokens, thinking's happening, reinforced learning with human feedback that came out of the Databricks event. That's going to put more demand for tokens, okay, which is going to push the curve for demand for large scale systems. So storage is required to have that kind of thinking beyond the first token out. Okay, speed, great, check that box. But then with memory and with these foundation models, especially computer vision, with robotics, a lot more tokens will be needed. What does this do to, well, first of all, do you agree with that? I'm sure you do, but if you don't, we'll debate it. But if that happens, that changes the storage requirements. And what changes specifically?
For us, John, it's typically when what we understand from a tokenization of the whole AI data center is the need, whenever you generate a token, you have to kind of, your data needs change during the whole data pipeline. I think everyone talks about the AI data pipeline. Fundamentally it's data, and data needs to be stored, whether it's at the start, whether it's during ingest, whether it's during your extract, transform, load, whether you're doing training. You're talking about robotics, which is more of the inference and at the edge. It needs to be scalable. I think David talked about it to be small so that it has power consumption constraints, which it has to take care of, and it has to be scalable. We don't know what density points an edge AI robot might require 10 years from now. We at Solidigm are always looking at pushing the density envelope to give our customers the largest density at the smallest footprint. The more data you have in a single drive, the less space you need. So in an edge use case, you're able to pack in a lot of exabytes in a small footprint.
And that's where you guys come with the form factor. But let's take the data center, for instance. You know, I was talking to Shad, who runs all the data centers for AWS, and they're doing $20 billion deployments. This is not a real estate deal in getting a data center. This is a design of a computer, basically, a supercomputer. The whole facility is now looked at from a design perspective. How does that change the scope of, one, how it's built, and two, how it's utilized? Because it's power bounded, okay, energy is going to bound it, cooling, maybe you can take a different approach, or rack configuration.
I think we are on the cusp because flash is now being designed in as the capacity tier. It's going to make some major differences. We'll see over the next 5 years adoption of direct contact water cooling, right, for storage. It's never been done before. Solid state's going to make that possible. Probably see the last vestiges of mechanical hard drives, the hot swappability and faceplate space. We'll probably see that abandoned in the near future to get higher density using the depth of the rack. So I think there's going to be some major transformations to form factor, function, around how it's cooled, how it's integrated, to leave behind, finally, the inheritance that we got of hard drives and the premium on faceplate space to be able to slot it. You know, the form factors that we inherited, there's going to be major transformation around that that's also going to facilitate liquid cooling and other things, because these data centers are going to high temperature. You wouldn't even be able to put in hard drives if you wanted to, because it's running at too high a temperature. It has to be silicon to be there. And it has to be cooled with not just liquid cooled, but high temperature liquid, direct contact.
What does that do for the practitioner? Oh, you want to go ahead?
No, absolutely. I think I'm aligned with David, but before we get there, right, today's systems, you have typically liquid cooling to, only for the GPUs and the CPUs. Storage requirements are going up in terms of wattages when you go from a Gen 4 PCIe to a Gen 5 and soon Gen 6. So today's infrastructure does require some innovation on the coolant front, and that's where I think, John, you were there at NVIDIA GTC, where we introduced the world's first liquid-cooled SSD, where you have the coolant coming and touching the cold plate, cooling. I have actually a product here for you.
It's so small, it fits in his pocket.
So
it's
this
smaller than an iPhone.
it's the same form factor, where you have innovations happening at the form factor level.
What's the capacity of this?
We can go up to 16 terabytes on those. Those are E1.S 9.5 mm SKUs, which are directly connected to the compute.
Does this work?
Yeah, those. That's
Thank you.
That's actually right. Yeah. So I think you talked about a solution where eventually there'll be liquid directly connecting to the.
You're already doing that.
But this we're still cold plate, but it's still in industry first.
There we go.
And again, shows where storage is not just storage anymore, data platform on one side, essentially really critical infrastructure on the other. Hao, what are you working on now? Because last time we chatted, the systems were being networked together. Networking is a big part of things. You got to connect these systems. They got to get the data moving from point A to point B across multiple coordinated systems.
Yeah.
Distributed computing 101 meets large-scale AI.
Yeah, correct. So that's why we really need to focus on optimizing along the data pipeline. So as David mentioned, on the storage side, we need more capacity. More capacity also means more power saving. Imagine that if we can put hundreds of terabytes in one small factor SSDs, that equivalent to a whole server in the past with HDDs, right? And you have one server of this, and it was to the whole rack in the traditional architecture, right? And David is developing amazing software to make that really working efficiently to optimize the power and footprint for the data center. Yeah. And Solidigm, Avi is, I think they are front runner on the large capacity SSDs to really help on that. While at Scaleflux, we are developing more and more efficient chips to enable those capacity and in the system. Yeah. So this is on the storage end. And then move to more the compute side, the more performance will be needed, because the more performance also means more efficiency of using the compute power, also means power saving, right? That you probably recently heard that the NVIDIA is pioneering the concept of the storage next. How about we boost the performance by 10 times, 20 times, right? And that's going to make the GPU computing even more efficient to reduce the data movement. So that's why we need both. It's a data pipeline. We need to optimize the whole pipeline to make the most efficient infra.
Hao, it's great that you brought up GTC. I did see that slide on stage from Jensen, and the scuttlebutt around the storage aficionados around me said, which one of those are AI native? And I'm like, that's a good question. So I'll ask you guys, the experts, what does AI native storage mean? Because I think this is where we're starting to see the transition from large hyperscalers who have been doing stuff for a while. As practitioners, they got the design side down at large scale. Now they got the enterprise just sitting there kind of feeling like they're modernizing, or that's the buzzword, meaning they got to get their you-know-what together. So,
well, if we look at where it's been going, it's been about disintermediating the touch points along the way. The whole GPU direct was all about getting the host root complex out of the data path when it arrives at the client and gets into the GPU without having to get copied through memory. That's great. I think we're going to see the same thing on the storage side. To get to ever higher densities and ever lower power, architectures like Hammerspace allow you to disintermediate the need for storage servers altogether and have flash that's more directly connected to the network. So completely bypass it. And it's funny how history repeats. The whole early days with Fusion IO and the flash becoming the performance tier, a good part of that was stepping over the legacy buses and controllers and storage networking. And now what we're seeing is the next step to get to ever higher density and more direct connectivity is to disintermediate the storage server and the fat software stacks that are needed to turn that into usable data. So when you talk about AI native, I think, okay, all the shit that can be bypassed so that things can be closer, because at the end of the day, it's about reducing that distance
And density
time.
too is a factor too.
And density, which is all gated by the power consumption. So at some point, we have to disintermediate the whole notion of a wall between the flash and the client that is a proprietary storage system, and have it so it's a more open platform with flash more directly connected on the network, accessed in parallel with direct zero copy.
All right, Avi and Hao, react to that, because what he's saying is it's an architectural shift, because you can't have the old way, whether it's an accelerant or offload or old architecture. What is the new architecture from your perspective? First, do you believe what he said to be true, and then how would you describe the new infrastructure?
I think absolutely, John. I think any innovations which lead towards lower latency architectures are the right step forward. When it comes to kind of the way we see storage evolving at this point, especially there's one hungry GPU who always wants data, and you need fast, low latency SSDs very, very close to it, direct attach. And there is this second set of data, I think network attached, which could be on an Ethernet in future. Right now it's still PCIe based, where the focus is all about density. The goal there for AI data center operators is density per dollar per density, while the goal for the other one, the compute node, is IOPS per dollar, where you need millions of IOPS feeding the data back and forth in between the GPU. But this architecture does require a scale-up architecture, which requires the densities to grow at the same footprint and allow incremental TCO for the AI data centers to build on. So,
Hao, what's your reaction? Obviously, density is big, close to the target, packets moving around, physics play into this. Yeah.
Certainly, I think it's a radical shift. It's from all the stack, from the chip component, subsystem, all the way to the rack level. If you can imagine, with one rack, in the future, we're going to store exabytes of data, right? And that's in the typical was a whole data centers of data. And once that happening, we're definitely on a journey as very different.
If you were designing a data center, say you and I were, college roommates, hey, let's design a data center to power the region of, the Middle East. We're in Riyadh, or we could say North Carolina. Amazon just did a big $10, $20 billion deal down there. How would we design it, Hao? And you guys could weigh in too. How would we think about it from clean sheet of paper, knowing what you know, power requirements, rack configurations? How would we look at the design thinking? As practitioners, what would be our approach?
I think number one, there's no more hard drives. That's clearly the picture.
We can all agree on that.
We'll all agree on that.
Spinning disk, spinning rust, as they say, is gone. Okay?
And number two, every AI data center, greenfield data centers right now are prioritizing their capex investments on the GPU. So they want the rest of the components to maximize the investment portfolio. So what they're looking for is you have your TCO, you have your density needs, you have a fixed power budget. And within that power budget, what's the maximum density I can provide in that data center for the compute nodes? And obviously, once you've moved on to the SSD, you are saving power. In an AI data center, there's nothing called an AI saving power in per se.
You use all the power.
So you reroute the power back to the GPU, or you add more GPU components for the powers you save by doing efficient storage. I think using Scaleflux optimized controllers, Solidigm SSDs, and then Hammerspace solutions, you're looking at efficient storage, or in actuality, where you're giving the data center the best TCO to maximize its capex investment on its GPUs.
Yeah. I think the efficiency is the key. If let's take Jensen's word, scale up first and then scale out. Right? So if we can do things in most efficient way on both scale up and scale out, that's where we want to be in our future.
Yeah, and the silicon makes a big difference to your point.
So I think specific from the architectural point of view, that means the performance tier of storage actually moves into the compute tier. Local NVMe inside of the GPU servers themselves becomes the shared storage tier. You're not going to get better connectivity than between the GPUs. And this is especially important for cloud architecture because the networking in the cloud is a very difficult problem because it's very spread out, very wide. So if you can have the performance tier live inside of the compute nodes that are on the same interconnect or fabric, now your performance tier is as high as it's going to get because it's in close proximity. So the performance tier is going to move forward. We talk about that as tier 0. And the capacity tier is going to shrink, disintermediate the servers, and be something that's more directly connected on the network and at a somewhat higher semantic level, speaking file as opposed to raw block. Because block would require that you put some layer out front, an intersection that has to reroute the data and put a file system on it. So we're going to see the file system evolve back into the SSD, and the SSD get put more directly on the network, much higher density. So the way you get the efficiency is having the storage dissolve into the compute tier, or have the storage server dissolve away and have flash directly on the network.
So either way, the tiering, these bottlenecks will go away. I mean, just network hops.
They have
on
to.
the scale up.
They have to.
I mean, you can go
And
down
that's
to
what we
2
mean
hops
by
now.
AI
with the
native,
last-
is that those things get factored out.
I mean, right now, 1 hop savings just can give you max performance. Scope that for the audience that doesn't understand some of the scale up challenges, because as you tier things, storage and networking, the hops matter. Talk about the importance of the hops and why that.
Well, if you count it today, from a traditional NAS storage system, the data has to go through 10 retransmissions between chip to chip or over a network cable 10 times, because it gets sourced from NVMe, goes through the root complex, out the network adapter, back in on another controller node, through it. By the time you get to the GPU, that data has been transmitted over a bus or a network 10 times.
All right, so scope the consequences of that, because that means what? That you have potential data loss.
Every single one of those things is
And-
power burning to make to signal.
Idle GPU times,
Well, it
maybe?
means the GPU sitting idle. All of that is latency and power burning along the way. GPU Direct got rid of 1 of those 10, right? Because now it didn't have to go through the host root complex, went straight into the GPU. NVMe over Fabrics gets rid of 1 of the remaining 9. We're down to 8. The way you get rid of the vast majority of them is using a parallel file system architecture. Parallel NFS lets you get rid of 5 of them because you don't need a controller node anymore. And then you start putting the flash device
All right, so
directly
I lost count. Where are we? 3?
So that's down to, that's down to 5.
Okay, all right.
But if you put your compute tier, if you use local NVMe, you can reduce it to just 1 hop, right?
So that's where we're
It's
getting
in the
to.
compute node. Or 2 if it has to go RDMA to appear. So that's the performance tier becomes 1 hop or 2 hop instead of 10 away.
Yeah.
Right. And then the capacity tier is even only 3 away if the SSDs are natively
So
connected to the network.
that's a constraint we're designing around if you're a
Yeah.
practitioner.
That's why I call it a radical change, right? From not just component level, but the whole system level architectural design, as David mentioned, right? So we need to look at this thing holistically, right? There are so many hops in the past, and it's not efficient.
That's a huge deal. All right, so let's pretend, I love talking to you guys because it's like OpenAI, NVIDIA, you guys see the future because you're in the systems design, who you sell to are making roadmap decisions out without giving away trade secrets to your customers that you work with. What are the key architectural things that we're going to see unfold over the next 18 months? Because these kinds of innovations are on the table. I'm sure there's some other stuff. You talk about silicon, you're probably in design cycles. You guys are in design cycles now, at least, and they've shortened down to what, 8 months? Not 18?
So I think first things, it's since the AI wave, you've seen a substantially large amount, almost all of it, the attention being on the GPU and the HBM. Now, over the next few years, what you are eventually going to see is people realizing that's not enough. We need efficient storage, scalable storage, and as a result, the things in our pipeline, obviously, we're in the Gen 5 world right now. We'll move to Gen 6. That focuses on the bandwidth portion. We'll keep on the wave of high density. I think I have here just to show another show and tell, John.
Does this work too?
This works too. And
hey, thank you.
Yeah, this is
CUBE tax.
122 terabytes on a single form factor.
Yeah.
You have a robotics team here in the event here today. Imagine 8 of those on a backpack behind a robot, and you have 1 petabyte.
Yeah.
That's today.
Yeah.
And we're not going to stop. We're going to keep pushing the advancements on the
and with the design, with kind of some of the examples we went in the weeds on around hops and areas, efficiency is going to be there, more power efficiency.
Yep.
All right, so the question then to you guys to wrap up is, when in San Francisco we're going to see the population of robots surpass humans? What year? 10 years? 20? Pick a year. Take a guess. Who wants to jump at that first? David, you're looking like you're ready to go.
I think we'll see serious in about 5 years. I think we'll see.
You'll see humans be less than robots.
I think we'll see some remarkable things happening. I mean, with LLMs and language models a couple of years ago, it sort of started passing my Turing test of being equivalent in intelligence. And now it's to the point where using those tools can literally make you feel superhuman, accomplishing things that would have taken years or been nigh unto impossible before.
You can get a PhD by going to OpenAI and paying 30 grand and get a
That's
PhD.
right. I think the realization of that in the mechanical with robots is only a few years away, and will be a game changer.
And by the way, speaking of robotics, we didn't even talk about computer vision. I mean, they're going to require very strong storage, strong compute. Thoughts on robotics, computer vision? I mean, they're going to need to see.
I don't have a viewpoint on when robots are taken.
No pun intended. No viewpoint.
We got distracted.
But I do. I'm a big fan of what Jensen said, right? Where by the end of this year, every workforce will have the opportunity to add 10-fold AI agents for each of its employee and workforce base. 10x or 50x the productivity. I think that is the key one, where instead of doing 10 projects, now we can do 50 with the help of AI. I think that's where Solidigm is kind of focused on, is looking at opportunities where we take advantage, whether it's in design, manufacturing, supply chain, on bringing certain AI solutions into our corporate environment to increase the productivity of our workforce. So.
Yeah, I believe in a few years you will see a lot of those.
5, less than 5?
I would say less than 5.
Once home penetration happens, I think that's when the numbers skyrocket.
So one thing that everyone should pay attention is the robotaxi. So I think Waymo and others are ready to spread more, right? Not just in San Francisco.
Yeah.
Once that happens, it's already
you already see in San Francisco, Waymo is already eating into Uber.
That's right.
Numbers, and people who are happier with no driver.
Yeah.
They play music, your name's on the marquee. It's like they can go into neighborhoods, you don't have to worry about getting canceled on.
Mm-hmm. See, that one has every elements of the robots, right? The computer vision and the processing, and then it's just different format of robots. And that's why I'm seeing that's coming soon, very soon.
Well, I'm grateful for all of you, for one, being CUBE alumni and also being part of this great event as we kind of mid-year. Put a plug in. Each of you go around and talk about the cool things you're working on, breakthroughs, round of funding, something you're proud of, a story. How we'll start with you. Talk about a breakthrough and put a plug in for what you're working on.
So we're big on the future storage, especially for the storage NX. We believe that's something that in the data storage domain is going to further boost the efficiency of the future AI compute infra, and also more densities. Okay, so those are the things Scaleflux has been very focused on to be essential building block and a partner for AI ecosystem.
Yeah, reliability is going to be key.
of
as
course.
the silicon comes in. Avi, what are you working on? Tell a story. What big breakthrough? I got a few props
I'm-
here to show a little bit of the breakthrough. I love
Yeah,
this.
I'm honored and proud to kind of represent our entire Solidigm team. We have one of industry's broadest, fullest AI portfolio, the fastest SSD, the densest SSD, the first liquid-cooled SSD, and that's, I think, a true testament of our team putting a solution mindset versus just focusing on kind of our storage component. We believe we will be an integral part of the AI ecosystem and working with the right partners, and obviously.
And the big breakthrough for Solidigm, people don't understand. What's the big breakthrough?
Oh, it's our floating gate technology, right? We've been the pioneers of bringing quad level cell into the market. The first one back in 2018, and ever since, this is the one which I showed you is our 6th iteration of QLC technology, which is what is going to bring the world's highest density SSDs into the market in the future. So I think
Keep bringing those SSDs. We love solid state. He knows we love flash. David, go ahead. We'll wrap us up.
So our thing is, you shouldn't have to choose between having a high performance file system, supercomputer class performance, and something that's plug and play, easy to use, easy to deploy. Right now you have to choose which of those you're going to sacrifice. With Hammerspace, you have parallel NFS based, native to Linux. You get the supercomputer class performance with something with the convenience that everybody knows how to run NFS. That's unexpected. Most people think NFS is not fast enough, but this puts it as world class. That's number one, but because it's standards based and native to Linux, it allows you to move the data into the compute tier. So you're going to be hearing a lot about our tier 0 technology, the ability to orchestrate data into the compute, where you can get this extreme performance.
Yeah. I love that little clinic of 10-to-1 ops tiers. Yeah. Thank you for sharing. Great conversation. Gentlemen, as always, great pleasure. Love getting into the low level because this is where the canary in the coal mine is. This is where the action's happening. This is theCUBE, the infrastructure and AI leaders are here with robotics. I'm John Furrier, your host. Thanks for watching.